Today we're looking at using the distributive property to multiply two numbers. And when we use the distributive property, we multiply a sum or difference by a number, and we multiply each number in that sum or difference by a number outside the parentheses. So we've looked at this with whole numbers a little bit, and then we used algebra tiles yesterday to practice this as well and kind of come up with some patterns. So what we're going to do first is kind of review what we did on Monday, which is when we used a distributive property in mental math to find problems like 8 times 53. So we're going to kind of review that. So if I do 8 times 53, we talked about how 53 can be broken down into 50 plus 3 to make it easier to multiply. So we would rewrite it as 8 times 50 plus 3. Then it's like we're distributing this 8 across everything in the parentheses. So everything inside of the parentheses needs to be multiplied by the 8. So showing that step, we would have 8 times 50 plus 8 times 3. From here, we get those products. 8 times 50 becomes 400, plus 8 times 3 becomes 24. And then our last step is to add those together. 424. Okay, go ahead and pause your video and try the 3 down at the bottom using that method. And then you can unpause to check your work. All right, go ahead and check your answers to those 3. Remember, on number 2, you could do 10 plus 9, but it's also okay to think of this as 20 minus 1. Number 3, I did 30 plus 7. Some of you might have done 40 minus 3, and that would work as well. Okay, now we're going to look at how this applies to fractions. So we have 1/2 times 2 3/4. And when we first did problems like this, we looked at changing the mixed number to an improper fraction and multiplying that way. So we're going to look at how we can use the distributive property here. So let's just start by rewriting the problem. So we have 1/2 times 2 3/4. So one thing to think about when you have mixed numbers, that's really just an addition problem. So this 2 3/4 is just 2 plus 3/4. We just don't write that addition symbol in between there. So I'm going to rewrite this as 1/2 times 2 plus 3/4. So now it looks like what I just did with the whole numbers, and I can distribute my 1/2. 1/2 times 2 plus 1/2 times 3/4. So if I write that out, I have 1/2 times 2 plus 1/2 times 3/4. And then 1/2 times 2, these 2's cancel out, so that becomes 1 plus 1 times 3 is 3. 2 times 4 is 8. So then 1 plus 3/8, this just becomes 1 3/8. All right, so from here, you're going to turn the page, and if you will, pause your video and try this same method on 4 through 6 for me. All right, so you can go ahead and check your answers to those 3 involving fractions here. All right, now let's take a look at what we were doing with the algebra tiles yesterday, but now we're just going to go ahead and apply the rule formally and really look at that pattern that we started talking about yesterday. So we're going to use the same idea that we were here with whole numbers, but now we're going to have variables in there. So this first one, we have 4 groups of n plus 5, or 4 times the quantity n plus 5. So with distributive property, everything in the parentheses is going to be multiplied by this 4. So I'm going to take 4 times the n plus 4 times the 5. So it's like I'm distributing that 4 across those. All right, and then 4 times n, we just write that as 4n plus 4 times 5, that becomes 20. We can't simplify that any further, so we stop there. On the next one, 12 times the quantity 2y minus 3. So again, everything's going to be multiplied by that 12, everything in the parentheses. So I'm going to take 12 times 2y, and then this time we're subtracting 12 times 3. And then if I have 12 groups of 2y, 12 times 2 is 24, but leave that y on there. So we have 24y minus 12 times 3 becomes 36. That's as simplified as it gets. So that's our final expression. And on this last one, we have 3 numbers or terms in our parentheses, so that 9 is going to be distributed across all of those. So I'm going to have 9 times 6 plus 9 times x plus 9 times 2. So we end up with 54 here plus 9x plus 18. And then last week when we talked about commutative property, we talked about how you can switch the order. So if I switch the order, since this is all addition, of the 54 and 9x, I do that so that I can add the 54 and 18 together. So I end up with 9x plus 72. There is another option here. You could, in your parentheses, add 6 plus 2 first and have 9 times the quantity 8 plus x, and then distribute your 9. That would be another option. All right, go ahead and pause your video and try 7, 8, and 9 on your own. So number 7, we got 7a plus 14. 3d minus 33, and then 56 minus 28d. All right, last thing today is we're going to apply this to a word problem. So down here it says Jose is X years old. His brother Felipe is 2 years older than Jose. Their aunt Maria is 3 times as old as Felipe. So we're going to write and simplify an expression that represents Maria's age in years. So what we know is that Jose is X years old. Okay? So that expression would just be X. Okay? For Felipe, we know that he is 2 years older than Jose. 2 years older. So we're going to add 2 to the X. So now for Felipe, that's X plus 2. For Maria, we're going to keep building on that. She's 3 times as old as Felipe. So we want to multiply 3 by X plus 2 because that's Felipe's expression. So that looks like this. So this is the expression for Maria's age. So we found that. We're saying that's 3 times the quantity X plus 2. So to simplify that, we're going to use distributive property. 3 times X plus 3 times 2. And we end up with 3x plus 6. That would be the simplified expression for Maria's age. Okay, go ahead and turn this over and try the same thing over here with Alexis. So Alexis is X years old. Her sister Gloria is 7 years older. The grandfather is 5 times as old as Gloria. So you're going to write and simplify an expression to represent the grandfather's age. So pause your video and give that a try. Okay, so we should end up with 5. Alexis is X years old, so here's Alexis. Gloria's 7 years older, so x plus 7. Grandfather's 5 times that. 5 times the quantity x plus 7. Then I did 5 times x plus 5 times 7. So we end up with 5x plus 35.